Welcome to Engineers Mindset. Now let's say we are given the question z equal to sin x squared y, and we're asked to find partial z partial x, partial z partial y. Okay? So z equal to sin x squared y. So I will show you the normal approach. I will also show you the shortcut approach. Alright, so we say let u equal to x squared y. So that simply means now that z is equal to sine u. So in place of x squared, I simply follow it towards u. So z becomes sine u. So it means now that z is actually a function of u. So z can only change with respect to u. So I can now find the partial derivative of z only with respect to u. So partial z, partial u is simply cos u. So I have this. Also from u is equal to x squared y, partial u, partial x. When I talk about the formula method, I simply said if I'm differentiating u with respect to x, it means that y is kept as constant since it's partial derivative. So I'll simply keep y as constant. Now take the power of x and multiply by x. I'll have 2 times x. Then subtract 1 from the power of x. So I'll simply have 2 minus 1. So I have this. So partial u, partial x is simply, this is 2x. 2 minus 1 is raised to power 1 times y. So this is actually 2xy. So partial u, partial x is 2xy. But the question says you should find partial z, partial x. Okay, so from chain rule, partial z, partial x will be written as partial z, partial u times partial u, partial x, such that if u partial u equals partial u, I'm left with partial z, partial x. Alright, so partial z, partial x is now simply partial z, partial u gives us cos u. So I have cos u times partial u, partial x gives us 2xy. I have 2x. Y. So this is simply partial z, partial x is equal to 2xy cos u. But recall we said let u be equal to x squared y. So that simply implies that the partial derivative of z with respect to x is simply 2xy cos x squared y. Okay, so that's the normal approach. Now let me show us, let's use the shortcut and see if I see to obtain the same result. We have that z is equal to x squared, sine x squared y. Okay, so from the shortcut I said partial z, partial x is now going to be simply what? Differentiate the angle. The angle now is simply x squared y. So since I'm looking for partial z, partial x, I will differentiate the angle partially with respect to x. So with respect to x, I simply have this x squared y as the angle. So if I'm differentiating this with respect to x, I will simply keep my y as constant. Differentiate x squared. Okay, so simply this is bound to multiply. So I have 2 times x, then 2 minus 1. Okay, this will give me y into 2x is the power 1. And this is simply 2xy. So if I differentiate the angle, I will simply have 2 multiplied by x times y. So I'll break that down to xy. Then differentiate the three function itself. If I differentiate sine, I will simply have cos. So I'll have cos x squared y, which is still the same thing as what we have here. So that is it for the shortcut approach. The next question says you should find partial z, partial y. Okay, so let's see how that goes. Alright, so from z equal to sine x squared y, also let u be equal to x squared y. That simply now implies that z is actually sine u. And therefore, partial derivative of z with respect to u will give us cos u. Okay, from u is equal to x squared y. Now we differentiate u partially with respect to y. that means we're going to consider x squared as a constant. So partial u, partial y is now equal to keep x squared as constant, differentiate y, not forgetting that this is actually y raised by 1. So it means you use the power 1 multiplied by y, then subtract 1 from the power, so we have 1 minus 1, close your bracket. So this is actually x squared into 1 minus 1 is 0, so 1 times y will give us y raised to the power of 0. And of course, any number apart from 0 raised to the power of 0 is simply 1. So 1 times x squared remains x squared. So it means now that partial u, partial y is simply x squared. So this is so, then partial z, partial y is simply partial z, partial u, times partial u, partial y. So if I have this, I'll have that partial z, partial y is now equal to partial z, partial u gives us cos u, and partial u, partial y gives us x squared. So this is simply x squared cos u. But remember that u is simply x squared y. So that's simply now implies that partial z, partial y is simply